This is Group 15's Design and Manufacturing project for Dr. Rashidi. This video covers 10 selected topics that were researched inside and outside of lecture, and each topic will include a summary of what it is and its applications, why it's important or what value it provides to the industry, its capabilities, its limitations, and how it can be used to improve products.
All right, so our first topic is generative design. What is generative design? This is a design approach that utilizes AI to create and test multiple design options based on specific goals set by the designer. And some applications include the automotive, aerospace, architecture industry, and consumer products and sustainability. So the importance of generative design, it allows rapid exploration of multiple design alternatives, enhances the overall design process, and optimizes each design option to meet specific design goals quickly and efficiently, and just overall streamlines and automates the design process, which will rely less on human interaction. So some advantages and capabilities of generative design include improved efficiency during the design process, the optimization of performance, also rapid prototyping like we spoke about before, enhances the creativity and innovation, and there's also multidisciplinary applications to this. Some limitations of generative design include limited human creativity, it minimizes the human aspect, cost of implementation, there's computational demands, the quality of results. AI can be unrealistic sometimes. The intellectual property concerns with AI generating the design, the ownership is up in the air. And there's also the complexity of the setup. There's a steep learning curve. All right, our next topic is digital twins. What is a digital twin? They are virtual representations of a physical object, system, or process. Some applications include the manufacturing industry, healthcare industry, urban planning, aerospace and automotive industries, and a lot of them involve prototyping and testing a virtual object. So the importance of digital twins allow for digital testing, obviously. It increases the opportunity to innovate, also reduces the testing costs of any prototypes you want to test, and it's also widely considered the future of innovation and design. Some advantages include faster innovation, there's also predictive maintenance, risk mitigation, performance optimization, training and simulation, and the remote operation and control. So some disadvantages with using digital twins include the high initial investment. There's also limited applications. It's not suitable for all systems. There's also uncertain return on investments. It's also very difficult to measure how much benefit you're getting from the digital twin. And also the maintenance and upkeep of any of the softwares, you need to update them and software ages over time.
Design for reliability involves assessing the probability of a product's success over time and combating issues that will compromise its functionality. So the 4 steps are to identify potential failures, design solutions to the failures, analyze the solutions with FMEA or a fault tree, and then test those solutions. The value in doing this is that it establishes trust with the customer and it reduces warranty claims or potential lawsuits. The limitation, on the other hand, is that it requires a lot of technical insight and time to identify possible failures and causes. So an example of the fault tree, or what it would look like for something like a spacecraft, is on the right, where the issue that would compromise functionality is at the top. So here it is the spacecraft spinning too fast. And everything below that are combinations of things that would work together and cause this spacecraft to spin too fast. So here you have things like motor failure or software issues or valves being stuck open. And all of these things would lead to a failure that would compromise the functionality of the spacecraft. The next selected topic is a combination of 2 things, human factors and ergonomics. Ergonomics refers to optimizing human product or human environment interactions, and human factors are the metrics of humans that influence those interactions with the product. So the value of making products more comfortable or easier to use is that it increases productivity because the user is, again, more comfortable, and it does save more money in the long term because it's less medical bills to deal with, and fewer workers' compensation claims or lawsuits. In the picture on the right, you have a user using their laptop without a laptop stand, which is putting a lot of stress on their spine because they're crouched over. And after incorporating a laptop stand, their eye is level with the screen, putting less stress on their back. So this is just an example of what considering human factors would look like during product design or setting up an environment for employees. A limitation of keeping these things in mind is that the research needed for it can increase product development time and immediate costs.
Another really interesting topic is product benchmarking, which makes use of parameters to see how a product compares to competing products in the market. An example of this application can be seen in the following table, where a company's product is being compared to three competitors. First, it clearly suggests the performance improvement. Since the company only scores 3 points in both pricing and place, this is what the engineering team needs to work on. The next step of design is perhaps design for cost, which lowers the sale price. Benchmarking also helps market positioning. Since the company excels in quality and partnership, they should definitely set the niche market as high-end customers. This information helps their users to conduct competitive analysis of the product to help improvement. The limitation of product benchmarking comes with three biases: biased method, biased data, and biased goals. Biased method may lead to inaccurate comparisons between products, impairing the effectiveness of product benchmarking. Biased data may provide false conclusions, which can either lead to false confidence or false doubt of products. Finally, if goals are biased, the entire design prioritization may be misaligned and will fundamentally affect the product's performance. The idea of cobots is short for collaborative robots, which operates alongside humans in a shared workspace. As compared to traditional automation robots, cobots have a general mechanical design and can be reprogrammed based on different needs and tasks, allowing it to have a lot more flexibility. Apart from that, the design of cobots takes into consideration of ergonomics and repairing. The intuitive design allows for a short learning curve, while the most common replaceable parts allows for maintenance of cobots to be significantly cheaper. Another benefit of cobots is safety, as it integrates sensors sensing the environment, minimizing the potential of a collision with human workspace. All of these benefits cobots grant increased productivity in manufacturing. To quantify the ability of cobots, MIT Startup Lab has conducted research which suggested that when cobots work together with humans, they can achieve 280% of efficiency than the total work they produce when working independently. This 1 plus 2, 1 larger than 2 effect allows cobots to be widely adopted in various markets, primarily in automotive and equipment industries where cobots replace humans in completing dirty, dull, and dangerous works. This frees human labor for more complex tasks such as designing better products instead of manufacturing them. However, cobot is still not perfect. As compared to heavy lifted traditional robots, due to the safety measures, cobots commonly only lift up to 3 to 30 kilograms. It also sacrifices a large percentage of operating speed to avoid collisions with humans. Finally, since cobots are designed to work with humans, they are limited to the working hours as humans as they are not designed to work unsupervised. The Internet of Things and Industrial Internet of Things both fall into the idea of having a network of devices such as sensors to collect and interact with the Internet, with the latter being a subset which focuses on the application of IoT in industrial applications. There are many instances in real life where IoT and IIoT can be seen. Common applications can include smartphone devices such as Amazon Alexa, wearable health monitor devices such as Apple Watch, and a lot of car real-time navigation system which takes into account of current traffic. On the industrial level, IoT is most useful when using sensors to conduct quality control, controlling the energy usage of factories, and also using sensors to model the failure model of machineries or devices and developing predictive maintenance schedules. The advantages of IoT and IIoT is primarily that they allow for real-time data monitoring, so that users are always aware of current conditions. This allows for product customizations as the collected data may accurately reflect the customer's needs. Another key benefit is that IoT allows for quantitative data decision making, increasing the precision of decisions. The disadvantage, however, is that both IoT and IoT relies on connectivity, bringing up a further concern of cybersecurity. Apart from this, since IoT and IIoT both rely heavily on sensors, there may be a high implementation cost, especially for IIoT.
All right, so this is retrofitting. Retrofitting is the process of adding a new technology or feature to older systems, structures, or equipment. Some applications include building an infrastructure, automotive, industrial equipment, transportation infrastructure, water and waste systems retrofitting. The importance of retrofitting, all old equipment needs improvements. With retrofitting, you can improve the old equipment. It keeps the industry up to date. It also retains or potentially improves the performance of existing systems and potentially increases the cost efficiency of that equipment or components. Some advantages and capabilities include cost effectiveness, extended lifespan, environmental benefits, adaptation to modern standards, improved performance and functionality, and technological integration, adding new technology to old equipment to improve its efficiency and performance. Some disadvantages of retrofitting, there are some limited effectiveness in some cases. There's also potential compatibility issues. There's disruption during retrofitting. There's also uncertain ROI, it could be a long payback period, environmental impact of the process, and technological complexities.
Lights out factories refers specifically to a manufacturing facility with little to no human intervention. The wording of lights out refers to the idea that factories may be operating 24/7, using minimal power, and finally able to operate in environments where it is hazardous to human bodies, such as chemical plants. These allow for efficiency boost, cost reduction, and no human error, which increases the overall quality of the parts produced. Few companies are able to almost implement lights-out factories, with most prominent examples including Fanuc's robotic assembly line, Amazon's storage system, Philips' razor manufacturing plant, and Siemens' PLC controller line. While lights-out factories' capabilities exceeds that of traditional factories in almost every single perspective, the limitation of lights-out factories is that they're extremely hard to implement. This is not from anyone else, but from the speaker of Fanuc, the world's current leader in this industry. Lights-out factories have at least 50% more in terms of set of cost, extremely high maintenance costs, risk of being remotely attacked by hackers, and finally, large technological barrier of correctly setting them up. These factors make lights-out factories an unachievable dream for many companies.
Lean manufacturing is the process of eliminating waste, specifically inventory, defects, overprocessing or overproduction, transport waste, movement, or unnecessary waiting. And all of this is done to continually improve a process so that more value is delivered to the customer. Implementing lean manufacturing saves time and money, and this is seen with Dakota Bodies, which is a truck body manufacturing company. They were able to reduce inventory levels and cut unnecessary waste to increase revenue by 20% and productivity by 5%. However, a limitation is that focusing on removing waste may put excess stress on employees who feel like there's less margin for error. And the focus on the present or the present process might redirect focus from future investments. And also, it's a pretty difficult strategy to standardize because it depends on the nature of each process or company.
And lastly, here are all the resources that we have used to make this project possible. And full disclaimer, this video is for educational uses only. And thank you guys for watching and have a great day.